Hello everyone. Today in this video we will be discussing the kinematics equations, but as a start I will be talking about what does kinematics mean and what does these equations represent for the kinematics motion, and what are these equations, if there is any conditions to use these equations. After that we will be solving a simple example related to one or two of these equations. But I will follow this video with a few other videos related to a motion in one dimension where we have to use the kinematics equation to solve the problems. Now, kinematics, it is one of the branches of the mechanics. So when we study the basic physics or physics 1, which is the mechanics, you have to come across the kinematics equations, where we describe the motion of an object moving in one dimension after considering all the forces acting on the object to cause the motion. Now, this motion, as a one-dimension motion, it could be either on the x-axis or the horizontal, or it could be on the y-axis, so the motion will be vertically, which is going to be more related to a free fall or an object being thrown from the top of the building to the ground, or you throw an object from the ground upward to the space. So all these equations or all these motions considered to be a one-dimension motion, and it will be following the kinematics equations. Now, these equations, the four equations we can see here on the right, where x represent the distance this object managed to cover after the motion start. The x naught here, this one is the initial position. Now v naught is the initial velocity, t is the time to complete the motion. Here we could say this is the final velocity, this is the initial velocity, and here is the acceleration of the object. And the other ones have different purposes, but they all cover the same variables. It's the distance, the velocity, the acceleration, and the time. And usually these equations can be used to solve for any unknown variables of these four: the velocity, the acceleration, the distance, and the time, assuming that the other ones is being already known. Now, something really important to remember, and it's really worth to mention, that these equations only can be used or valid when the object I have or describing not just moving in a one-dimension motion, no, it is under a constant acceleration, which means the acceleration of the object does not change with the time. If the acceleration change with the time, this is a different procedure, and solving the problem, it will not be falling under these equations. Okay, so here's the equations. There are four of them. Sometimes, in some cases, you might choose one of the, like, to solve a problem, you could choose one equation and your friend can choose another equation, and they both get to the same answer, which is possible. Sometimes I might use one of the equations to get me one of the variables, then I have to apply it on another equation to be able to answer the main question. It depends on the scenario and the situation of the question. Okay. Now, one of the things we could mention about the last equation here has a special thing compared to the top three, that it doesn't have time. The variable time, it's not involved in this equation, which make it a bit handy. When I have a scenario of a question or describing a motion of an object and asking me maybe about the final velocity after knowing when what was the initial velocity, the acceleration of the object, how far this object traveled, without mentioning the time, this equation is the best to be used. When I have a scenario and have nothing to do with the time, or the time wasn't really important in the scenario of the question. Okay, so let's try now solve an example about uh, these equations. So here I have Emmy is running the 200-meter track. So I can say that the distance is 200 meter. She starts from rest. That's a very important information. So the initial velocity is 0 meter per second and accelerates with a constant acceleration. That's important for me. We said this is the main condition to use the kinematics equation. The object must be moving within a constant acceleration until she hits the finish line. So it's reached the finish line. If it takes her 24 seconds, that's the time required to complete the whole running process, to complete the race. What was her acceleration? So I need to know how much the acceleration during the process. Now, if I go back one step and look at my four kinematic equations, I can see that I have the initial velocity, I have how far did she run, and what was the time for the entire uh, or the time required for the whole running, keeping in mind that she started from zero, or like the reference position of her is zero. It will be, this equation is the best one to help us answering the question. So I can say, all right, that's x final equal x initial plus initial velocity t plus half acceleration squared the time. Okay, now uh, the final velocity, oh sorry, the final distance is 200, started from 0. Now the initial velocity is 0 times the time, that will be also 0. Then I have half the acceleration, and the time was 24 second square. Now just by rearranging the formula, it will be the acceleration equal 2 times 200 divided on 24 squared. Running that by the calculator, it is that will give us 0.69, so we can say it's 0.7 meter per second square. That was Emmy's acceleration during her running for the 200 meters. Okay, so this is the kinematics equations, how we use them, under what conditions, why we use them to describe, to help us describing the motion of an object in one dimension. In the next videos, I will be trying to solve more problems related to the kinematics equations. I hope you find this video useful, and I will see you again. Thank you.